So, hi again to everybody out there from Vienna. My name is Stefan Komornyik and I'm managing partner at HAKOM. First of all, I have to announce a change for today. Due to a quarantine, Ricardo Wickert, our head of R&D, has taken over as a speaker from our CTO, Thomas Hasida. But don't worry, Thomas is okay and Ricardo is the perfect substitute. So I'm happy to welcome Ricardo and Martin Otzelberger from Force. Hi.
Hello, everybody.
Hi. Last time we talked about power quality, the health index of our electric energy systems. And thank you very much for the numerous and positive feedback we got. This has really encouraged us to continue looking for interesting topics. And I think we have found what we were looking for. Today, we will take a look at the backbone of the data-driven energy industry. And guess what? It's mostly about time series again. In 30 years work for the energy market, our focus is and has always been on time series, as we regard them as the elementary particles of the energy industry. And with more than 100 companies in over 15 countries already using our time series technology, it is our mission to make energy data valuable. But first of all, let me introduce Force. Force Partners is a team of proven experts who have an impressive track record. They have been providing consulting services in many different domains for many years now, with a range from management consulting, business consulting, digitization to solution design. Among other things, they are experts of the energy industry, and therefore we ran across them on our journey through the European energy markets last year. We have found that they have an extremely clear view of the current disruptive developments in this market. They analyze the extraordinary challenges and offer real solutions for utilities that want to actively seize the opportunities of energy transition and digitization to best leverage their capabilities. So I'm especially proud to welcome one of their managing partners, Martin Otzelberger, today. Thanks again for joining. But before Martin takes over, let me start with some general considerations about availability and quality of data nowadays. What is the typical current data situation in companies working the energy markets? It looks scary, doesn't it? Therefore, I called it the energy data jungle. We have countless data sources that store their data in various databases and then make it available for different apps. But don't worry, I won't go into detail here. Let us just focus on what use cases typically need here. Assume you want to create competitive offers for your customers in line with the market within the shortest possible time. It is not only profiles that you need, there's also a lot of other data like prices, tariffs, and more, depending on the complexity. Just think of different scenarios you might want to calculate, or think about forecasting changes in the feed-in from renewables. You want to do that extremely quickly in order to determine your new market position, and ideally, you want to do that in real time. Now, once again, you get data from different sources, and you need it fast and reliable. This creates great pressure. Our experience shows that this leads to a lack of data quality. Data might be incomplete, some of data might be missing. In some cases, storages might not even be available when you need them, and you might not even notice it. Often there's also inadequate governance. Who is responsible for data quality and availability? As long as there's no one responsible, no one feels responsible, and data quality will be treated like a hot potato. And there's another use case killer, inconsistency. Without a centralized, unified approach, data is not harmonized. And we all know if you do the same database calculation task in 3 systems, you will get at least 3 different results. All of that leads to automation errors. And you might now object saying, why automate things? But there's no way around that. Thinking about the sheer volume of data and the lack of time, this will make you automate whatever is possible. So what is the way out? There's no such thing as a magic formula. There are rather some principles to follow, regardless of technology or specific use cases. It is what we would call a data-driven culture with some general elements. Data quality is not only a technical issue, but more a social one. It needs the respect it deserves and it cannot be compensated for. And of course, it needs budgets and clear responsibilities. Automation is key to success. Whenever possible, automate. Don't worry, there will be plenty of work left for everyone just to define the automation rules and keep things running. Data in general, and especially time series, are the backbone of digitization. Therefore, time series management is a key factor to success. This culture should drive your architecture. And with that said, I would like to hand over to Martin to talk about a suitable data-driven approach that takes care of all that that I talked about right now. So Martin, stage is yours.
Yeah, thank you. Good afternoon, everyone. Thank you very much, Stefan, for inviting us to your HAKOM webinar. And as you might have guessed already when getting to HAKOM webinar, and we heard that it's about time series and in my case also a lot about market data. In our experience, managing time series efficiently that's a major building block for all initiatives in the energy industry. Time series are everywhere in your processes and therefore systems. When speaking to clients, we see that everyone has very similar questions and items to solve, but is using completely different approaches and technologies when designing solutions. Typically, we use a capability-driven approach to develop the best suitable time series or market data solution for a client-specific architecture. In our experience, the best way to develop a suitable architecture is to start at a business problem. So imagine you're operating an offshore wind farm. The sea is stormy, the waves are high, and wind is strong. The rotors are spinning quickly and produce power. Of course, this is what you want. But what does it all mean to you from a data point of view? Good news is, in the end, all the data are time series. Data providers are delivering frequent updates of various weather forecasts. And based on these production forecasts are calculated and other algorithms, such as optimizations, aggregations, within trading departments start calculating and using these time series data. To sell the generated power in your wind farm, you also need to place orders on markets somewhere in this process. Ideally, you generate these orders automatically and place them in a 365 and 24/7 fashion. So that means constantly. This example should show us that most activities in power generation and related trading activities are based on time series data, especially when activities have to be repeated over and over again. So from this wind farm example, we see clearly that a very solid data architecture has to be put in place, which is capable to also reflect growing data sizes and increasing complexities due to the energy transition. We want to guide you through such an ideal data architecture today and want to explain what capabilities such a data architecture needs to have. So first, we must know the data that is relevant to our business. That's a very simple point. But knowing all the data available across an organization can be extremely challenging. Just think about Excel sheets. Sometimes sent via emails, stored in network drives, or even on local drives. So no matter what, building this inventory is your starting point. So as a first takeaway, know your data fully. The next point is to put clear responsibilities on data governance in place. It will help the organization achieving the desired level of data quality on a day-to-day basis. Also, it is paramount to put sustainable costs and license control into place, especially when we talk about market data. So as a takeaway, make people in your organization responsible for data. And as a third point, the data must be available consistently and reliably to serve a bigger number of downstream processes. These processes will rely on the data and the number of processes might be very high. Achieving consistency across these processes is therefore absolute paramount, but will enable you to develop oversight and control within your data architecture. So takeaway number 3, consistency is king. What are the capabilities a time series data architecture must meet? So when we come back to our initial example, the weather forecast was a starting point for other processes. In the energy industry, it is quite typical that a lot of external and internal time series data sources exist. So during the last 15 years, we've seen in our projects that mid-sized utilities have easily around 200 different time series imports used in trading departments. And big players even have more than 1,000 different imports, only external ones. In our projects at Force, we also see that in addition to the imports from the external data providers, there will be a high number of internal time series imports of the same size. So the way to implement such high numbers of imports is to build or buy a well-designed import layer, including a powerful generic feed framework. The better the design of this layer, the more long-term benefit you will experience. So looking back in our project history, a buy solution was most appropriate for many companies. Another central capability of this layer, when you have to monitor a lot of imports, is a reliable and fast monitoring of imports, external and internal ones. So you will execute quite many import jobs in a 24/7 operation, and this needs to be monitored accurately. Otherwise, you're falling behind very fast with your processing. So we've now collected all the required data for your processes, and now we need to store it efficiently. Storing and managing data, that sounds simple since database technologies are around for quite some time. And we see technological inventions around time series for over 15 years now. Not many of them stick around as HAKOM does. And time series have a clear structure. So data is only indexed by date and time. Therefore, we think that using generic data stores or data models will not deliver an optimal solution. We would recommend time series optimized data stores. But building an optimized time series data store, that's certainly not a task for a lazy weekend. In the end, the details to get it right are very complex. Or why would HAKOM focus on this topic over so many years if it would be simple? Basically, you need a time series optimized data model, and then you need to focus that your software scales linearly with a constantly increasing number of instruments and date time items to be stored. So not many systems available, not many available solutions on the market scale linearly with increasing amounts of data, versions of data, and the full-blown history. When we come back to our example of the wind farm, we constantly need to store updates on the local weather forecasts and need to take care of that these are right. So if you don't automate this, including the validation, then you will not make it. And even worse, this is only one type of data source that you need to manage in your processes. Another big argument for a fully automated approach, even when it comes to validation. So certainly exceptions needs to be handled manually by your data engineers. But in summary, a modern system setup must feature a high degree of automation. Typically, these are rule-based validations where the rules are constantly extended and improved by your data engineering team. And exceptions are corrected manually or semi-automatic. And a consequent fulfillment of all necessary governance and ownership structure are a must-have feature. Now the data is ready for distributing and using it. So most people don't spend too much attention on this, but we think differently. This is the face to customer layer. You should get this right. So this layer is the starting point for all downstream business processes. Potentially everyone in your organization connects to the API. So you should not change this too often, ideally never. Ideally, you define a stable generic API that's targeting a very small number of changes for the downstream systems. So in our experience, spend most of your thoughts on this API topic and make it fit for purpose for your organization. But most importantly, use something market proven. The API will be the key success factor for the future, since programmatic usage of data, for example, via Python scripts and models, is exploding. Let's now have a closer look at the challenges, but also the strategic aspects of an industry standard, time series data architecture. The energy industry uses a large number of external data sources, but keep in mind mostly internal sources exceeds the number of external ones. Strategically thinking, focus on getting external and internal data into your system fast. So don't spend too much time building everything on your own. It's a spoiler. Don't trust your first own effort estimate at all. Store and manage. Simple 3 do nots. So don't make building a better time series data store your first priority. It will jeopardize your project success. Don't waste your best developers in trying to build a better data store. And third point, don't start looking at performance. When your data is too big, look at the performance from the beginning on. Maintain and validate. This is your headache layer. Design and specify it from the beginning on. Make consistency and harmonized data your main priorities across a wide range of data sources. So this will enable you to provide your strategic goal to your data customers and deliver some high quality data for a controlled OpEx. And provide and distribute. So remember, this is your face to your customer layer. There will be a lot of users and systems connecting to the API that use the time series data of your system. So as a clear guiding principle, implement a generic API that doesn't require changes. Applications can connect and retrieve data, ideally in a self-service approach. Yeah, I hope we could give you some practical insights and ideas on how to manage time series data professionally and keep CapEx and OpEx in an acceptable range for your management. Thank you, and back to Stefan.
Thanks, Martin. I think that's really an inspiring approach coming from your capabilities and deriving clear requirements from that on. That gives us a good guidance. And now let us hear what Ricardo will tell us about how our technology will deal with all those challenges. Ricardo.
Thank you, Stefan. So as Martin just gave us a great overview of the involved capabilities in a data-driven architecture, just how does that look like in practice when we're dealing with a time series fabric such as that from the TSM framework? So here I put on the screen our TSM component architecture in a diagram depicting how it interacts with both the various persistence options on the right side, as well as with upstream sensors or downstream applications, so the clients and the processes on the left side. Our TSM service is placed in the middle with various features that I will highlight according to the role that they play when we analyze this view using the capability layers that Martin just presented. So we begin with the capture and collect layer. I'll make a note here that our domain layer is actually composed of a number of stacked components. So you see the many frames in the picture. And that is to symbolize that it runs on scalable resources. This could be a virtual machine with multiple cores, or more likely a number of containers, say in a Docker environment. Now, on the concept level, we saw how important it is not only to collect the data, but to provide a management layer for the whole process of gathering the information, where and when to fetch what. And in our case, this means integrating with various sensors. This could be your smart meter gateway, but also, as Martin mentioned, a lot of internal sources, so an existing database in your intranet, for instance. And the data is ingested through various interfaces. Here we're highlighting, for instance, our REST API, as well as a .NET or a Java component. And the main features that are relevant here are, of course, the speed to handle this ingestion, as well as the integrability with a wide number of formats, both on this receiving end, but also on the persistent side. We're acting as a middle layer to bring this data to different forms of databases. This could be traditional relational SQL databases, key value, NoSQL forms, and also some other novel concepts which combine the two. Now, the second layer concerns itself with the storage in the sense of the actual data model with aspects such as versioning, historization, audit, or archiving of the data. For instance, fresh data may be kept in one database, but after a while, it's moved to some other form of long-term storage. If we get different versions for the same time series, maybe that's not the case with the sensors, but happens very often, like Martin said, with the weather forecast. You have a later model run which replaces the previous one, or quotations or prices that can exist in many different versions from different days or different months. And it's very important to know which price time series you used when you made an offer last week, or what was the state of your weather last month when you made a long-term forecast before executing a trade and entering some position. So you need the traceability. This is how we're summarizing this set of functions, but also a data model that supports specific tasks. And this is where TSM gives you a lot of flexibility. On the one hand, accommodating different resolutions or units, but also a lot of flexibility, since this flexibility is offered out of the box. Now, moving on to maintain and validate, this is the capability layer that includes those elements related to the actual business management of the data. We may have validation and correction with rule-based support, or maybe even AI components to detect anomalies or extrapolate the data, and then actual tasks such as computing derived curves, training a machine learning model, or performing formula calculations. This may have an additional interaction with process automation components on the left, steering when to perform which tasks. So again, speed is very important here once we get in the realm of big data applications. And also a lot of flexibility is needed both in your processing engine as well as in your ability to integrate analytical libraries. And TSM offers you a very flexible formula engine with full access to all the math functions. And I'm here from R&D, so I can tell you we're also working on a number of features to integrate the framework with other libraries such as ML.NET, Python scripts, Keras and TensorFlow, for instance, for the most varied purposes. And all of this is useless if we can't then provide the refined data to downstream systems. So here we reach the last capability layer, which addresses how we integrate with those systems to distribute the time series with, I will call it, added value. Again, we have speed as a cornerstone and also the flexibility I just mentioned, but furthermore, we have the integrability highlighted. And here I'll emphasize how we offer a range of connectors from simple Excel integration to Grafana or Power BI, as well as a number of third-party applications that natively support HAKOM TSM. And if they don't, that's also okay because we offer standardized APIs, so it's very easy to get hold of the data. Again, with the great advantage that your consuming system on the left side doesn't need to worry about how to speak to the individual databases on the right or in which format the data is stored, since our middle components harmonizes this data. So effectively, you could think of it as a universal translator. So I think this gives a good summary of our architecture, and I hand back to you, Stefan.
Thanks, Ricardo. I hope you can see that we did a lot to make driving easier in this data-driven energy industry. And I have to say something right at that moment. When we started the webinars 1 year ago, who would have thought that we have more than 120 participants one day? So thanks at this point to all of you out there. So, but before we come to our Q&A session, I will ask Ricardo again for a short summary and some conclusions. And in the meanwhile, I do again ask you to send me your questions for the panel. Ricardo?
Thank you. So I think we have some conclusions from what Martin told us and also looking at our architecture overview. I think the first one is that there are functional and non-functional aspects involved. This data fabric must balance the business needs with a range of other non-functional elements. And we only indirectly covered some of them, how this is deployed, or we didn't even touch elements pertaining to the security or privacy concerns of the data storage. This would be a whole webinar by itself. Then those distinct layers help the understanding, but in reality, there's a lot of overlap between them. As we've seen, some of the features were often highlighted in different stages, right at the beginning all the way to the end. And this leads us to the next point, that one needs to consider the big picture instead of trying to solve the challenges one layer at a time. And last, I think it's very important to emphasize the need to balance this domain know-how with the technological expertise. And I think here it's fair to give a nod to our colleagues at Force that help you guide through the challenges that are involved in designing and implementing such a solution in the context of often very elaborate enterprise landscapes. So I think the takeaway message here would be to don't neglect that, don't be afraid to ask questions and go looking for help to avoid common pitfalls, but also to avoid reinventing the wheel on what can be a very complex structure. So back to you, Stefan.
Thanks, Ricardo. I can see some real interesting questions. Great, please continue asking. We'll soon start the Q&A session. Our today's call to action is a quite easy one. If you're interested in the approach or our technology, please just contact us at sales@hakom.at for more information and we will get back to you. So now let's come to our Q&A session. And well, thank you. Nice words I see here, but one kind of skeptical question, maybe one for you, Martin. We are indeed confronted with very large data volumes and currently evaluating data warehouse vendor. In which respect would a technology like HAKOM time series management still bring advantages here?
Yeah,
do you think?
That's a very good question. Thanks.
I hope you can answer it.
Yeah. So time series have a clear structure, so it's only indexed by date and time. So when it comes to the implementation details, things are getting, of course, more complex than just date time and the value. In the energy industry, we will have additional date dimensions, for example, delivery periods. Then versioning will be a complex topic to be audit proof, and especially when it comes to trading and market data. So that makes building a storage layer much more complex than it initially looks. And especially when a system must deliver very good performance for storing and loading data. So it's somehow near time. So we think the best approach is to use a proven technology that fits the time series purpose and that has already solved the complex topics. So we would recommend a time series approach here.
Okay, Martin, thank you. We have one maybe for Ricardo. Did I get it right? TSM HAKOM is proprietary time series database of HAKOM. Well, I can shortly answer this also. We are not actually a time series database. We use other persistences to actually store the data. This could be relational databases or in-memory databases or also horizontally scalable databases. We see ourselves as kind of a middleware and we do the time series processing service. So we are not a time series database in that sense. Ricardo, something to add here maybe?
I would come back to this picture. I recently came across a very interesting article with the term data fabric. So you could even have different data warehouses on the persistency layer, but with our component in the middle, you would effectively have an easy way to approach different data stores, different databases, without necessarily having to move data from one silo to the other. So we're really acting as a fabric that permeates this data landscape and allows components to more or less seamlessly integrate with data wherever it may be located. So as Stefan said, also a middleware would be an appropriate definition in this case.
Okay, thanks. There are some others. So next one would be, hi Stefan, HAKOM looks interesting not only for energy, but also for banking. Do you have some thoughts on using HAKOM as a capital market data system? I'll try that one. Yes, actually coming from the view of a mathematician, we do not see any energy specific in a time series. We have a very abstract view on time series. So actually we often thought of offering our time series technology also to other markets. But actually up to now we were kind of being absorbed by the energy markets, but we have a strategy also targeting other verticals. So it's a good question, and the answer is that's interesting, and we have some thoughts on that. Thanks for that. Another one, I think this one also goes to Ricardo. How do you handle the library management for external scripts, e.g. Python? Is it possible to import libraries or import requirements? Import requirements, yes. Ricardo?
So we have a connector that can easily allow a Python script to access data more or less transparently through our REST API. I think a detailed example would clearly blow the scope of the time that we have available, but basically we allow any Python scripts that would run in your environment that you would be in the control, in the driver's seat to how you orchestrate the compute resources in that Python script. They would seamlessly fetch data, do whatever processing they need to, and deliver it back to our API end so that we, again, deal with the storage layer. Effectively, we just deliver the time series right at the gates of your Python processing and fetch it back once the result has been computed. So you don't need to go about implementing storage and archival, for instance, within that context.
Thanks, Ricardo. I think we have time for another one. Understood for big data. I think this one maybe for Martin. Understood for big data, but we do not have that many time series. Why should we make the effort for a limited number of time series at all?
Yeah, also interesting question. So growing the system as it hasn't planned before, that's complex. So it can be very challenging at the end and depends very often on the system architecture and the implemented data model, changing that afterwards. So that can mean significant efforts or even implementing a totally new system. So even if you have only, let's say, 200 imports and reconnect all the downstream processes, that can really lead to significant efforts.
Okay, thanks. I think With respect to time, I'm awfully sorry, but we need to finish the main part of our webinar. There are still some questions out there. So if you like to stay with us for another 10 minutes after the outro, we can continue with the Q&A and we'll take up some more open questions. So please stay and we will wait and then let's have a private session afterwards. I think we can make it through all the questions. As usual now, I would like to mention our next webinar that we planned for May. Once more, we will invite some real persons of interest, and I hope that you will join again. Once again, thanks for coming, and please stay tuned to us. Have a good start into the springtime, and do not forget, life is a time series.